Now that we have all the components for the battery, now we want to label the components. The zinc side of this battery was where the source of the electrons was. So we can consider that terminal, that electrode, to be the negative terminal. And the negative terminal is given the name anode. The electrons leave the anode, go through the television, and are attracted to the other electrode. So the one they're attracted to is given the positive sign. The positive terminal is called the cathode. You always will have one anode and one cathode because you always have one oxidation and one reduction. The anode is always the site of oxidation, and the cathode is always at the site of reduction. We also want to put this together into one overall shorthand. So instead of drawing out the entire battery, we can just write a shorthand that has all the same information. The shorthand starts at the anode and ends at the cathode, and what connects the two is the salt bridge. When you look at the overall reaction, just like the way you read a reaction from left to right, the shorthand always has the reactants first and the product second. So for this battery, our anode is the solid piece of zinc. That's the reactant. That one's written first. On the product side, we have zinc 2+. That's a different phase, so to show a different phase, you put a solid vertical line that separates the two components. So we have solid separated from solution. Those are the only reactants and products that are important for the anode, for the oxidation. Then we put in the salt bridge, which is represented by two vertical lines instead of one. Then we look at the overall reaction. Copper 2+ is the reactant, so copper 2+ would be written first. That's in solution. And then the product is copper. That's a different phase. So we have another vertical line, and then we have our cathode solid copper. So from an overall shorthand like this, you can quickly see what's being oxidized and what's being reduced. Whatever's on the left, that's the anode, so this has to be an oxidation reaction. Whatever's on the right, that's the cathode. This has to be a reduction reaction.